In this problem, we're going to find the limit of a given function where the function is 3x squared minus 5x minus 2 all over x squared minus 4 as x approaches 2. So if you encounter this problem, there are like two ways, right? The first way is just substituting values, but it's in tabular form. Like, let me demonstrate to you. Right, we have an input of 2, right? We have an input of 2. So we must consider its left hand side or right left side and its right hand side. All right. So here, each of these sides they have their own like table. Wait, is it visible? They have their own table. All right. So this table has two columns. One is the x, and the other column is f of x. Which is the same thing goes on for the right hand side. So what are we going to do? So here, we're going to substitute x values that is closer to 2. So on the left-hand side, we're going to substitute x values that is closer to 2, but from the left. So like for example, 1. So if we substitute 1 in this given function here, what would be the answer? All right? Then let's make the x values closer to 2. Let's just say 1.9. So what happens if you substitute 1.9 in this function? Now, next, after whatever the result we have, we try to substitute 1.99. By the way, after you substitute, whatever value that it has, you're going to put it here, of course. Like for example, when you substitute 1 here, what would be the answer? So the answer here, you'll put it here, of course, all right? If you would substitute 1.9 here, the answer is here. If you substitute 1.99 here, the answer is here. And I think you get the idea. All right? So maybe I think you'll stop until 1.99 or as many as you can. All right? But I suggest I think until 1.99 or maybe 5 values as long as it's very close to 2. And we will do the same thing on the right hand side. Right? So for example, substitute 3. All right, substitute 3 here. What will be the answer? Substitute 2.1. What will be the answer? Substitute 2.01. What will be the answer? Substitute 2.001 and so on and so forth. Now, the thing is, um, whatever we substitute in this function, it's approaching to a certain value. So let's just say the answer here, like it's approaching, for example, let's just say it's 3. Again, example, right? Example. So if it's approaching to 3, then make sure that on the right hand side it also approaches to 3. And if they're the same, then that would be your answer. That's it. So that's the first way. However, I'm not gonna do that. Rather, what I'm going to do is algebraic manipulation. Okay? So basically, what I will do is just directly substitute it. But there are times where when you substitute, the answer will be undefined. So let's take a look. Let's substitute 2 in this given function. So we will have 3 times 2 squared minus 5 times 2 minus 2 all over 2 squared minus 4. So 3 times 2 squared, that's the same as 3 times 4. We have 12. Minus 5 times 2, that's negative 10. Minus 2, we have negative 2. All over 4 squared is 4. Now we simplify. Above, when we're going to add all, we will have 0 all over. On the denominator, combine them, we will have 0. This is an undefined answer. This is actually another type of undefined answer, which is in the indeterminate form. Indeterminate form. Basically, a fraction that has 0 on both sides. So what are we going to do in this case? So here we will manipulate the algebraic function. All right. So what do I mean by manipulate? So basically, it's like you're simplifying. You're simplifying a given algebraic function, or you're going to conjugate, or you're going to rationalize, and so on and so forth. All right. So here we can actually simplify this function. All right. So how can we simplify this function? This one. is factorable. This 3x squared minus 5x is factorable. Let's say we get its factored form. 3x squared minus 5x minus 2. What is the factored form of this trinomial? In here, I will use my own method that I always use, where we have a coefficient of x squared that is not equal to 1. So what I will do here is I will do slide and divide method. So first, I slide the coefficient of the x squared to the constant term. So I have x squared minus 5x minus 2 times 3. Then, I will multiply 3 by that constant term, in which I will have negative 6. Now, my coefficient of x squared is 1, okay? And then I have a constant term of negative 6. With that, I can easily find the factored form of this one just by looking at the factors of negative 6. Like, when you multiply these two factors, the answer should be negative 6. But that's not the only case that we're going to consider. Because, right, again, you're going to think what factors that when you multiply them together, the answer is negative 6, right? Well, not only that you're going to find those factors, but you will also take a look that if you're going to add them together, the answer is negative 5. Okay? So let's take a look. We have negative 6. We can have 6 times negative 1 because 6 times negative 1 is what? Negative 6, right? Now try adding them. 6 plus negative 1. What's the answer? Positive 5. So is it the same as here? Well, in terms of a number, yes, but sign, no. So we're not going to use 6 and negative 1. But how about negative 6 times 1? Because negative 6 times 1 is negative 6, right? Now we try to add them. Negative 6 plus 1 is negative 5. Now let's take a look. Is it the same as this one? If it's the same, then we're good to go. We're going to use negative 6 and 1, right? We're going to use that. Now that we will use that, what are we going to do? So first and foremost, right, we have uh, x, right? And that is the variable used here. So we will put two parentheses and put x here, all right, on the left. Then we will put each of these number to its own parentheses. So we have negative 6, so put here minus 6. Oh, wait, hold on. Put here a minus 6. We have positive 1, so put plus 1. But we're not done yet because, right, we slide 3 going to 2. So that means the next step is we're going to divide each number by 3. So negative 6 divided by 3, 1/3 divided by 3. So x minus 6 all over 3, that's x minus 2, right? X minus 2. Now here, 1 divided by 3 is like, um, basically it will not give you a whole number. It's just a fraction. So what are we going to do? What we're going to do is just put 3 beside x. So we will have 3x plus 1. And that is the factored form of 3x squared minus 5x minus 2. So we can simply rewrite that trinomial into x minus 2 times quantity 3x plus 1. That's it. All right? So that's 1, but we're not done yet because we have x squared minus 4. This one, we can actually simplify this. Let me just erase this writing. We have x squared minus 4. This is actually the same as x squared minus 2 squared because 2 squared is just 4, right? And if you're going to take a look, both of the terms here are in squares. So this is difference between squares, you know? So if you encounter like this, like for example, x squared minus y squared. For example, okay, like these two terms are squared, just like these two, okay? Then you can simply rewrite this as x minus y, x plus y. You can simply rewrite it that way. So for example, let's just say I have 4x squared minus 9, for example. So this one is just the same as 2x squared minus 3 squared. So we can simply rewrite this as 2x minus 3, 2x plus 3. So in this case, we can do the same thing here. So we can rewrite this as x minus 2, x plus 2. So we have here x minus 2, x plus 2. And that's it, right? That's the factored form of the denominator, all right? So we have the factored form of both sides, all right? Now, what are we going to do? Next, we will cancel out. We have x minus 2 above and x minus 2 below. So we can just simply cancel them. As a result, we will have the limit of 3x plus 1 all over x plus 2. So this is the simplified form or function of this given function. All right. So now what are we going to do after we simplify it? By cancellation. So we will now substitute 2 in this function. So 3 times 2 plus 1 all over 2 plus 2. So this is 3 times 2 is 5. No. 3 times 2 is 6, right? Yeah. 6 plus 1 all over 2 plus 2, 4. So your answer is 7 all over 4. That's it. This is the answer of this problem.